Have you ever wondered what the first species on Earth was? A question that has intrigued many a curious mind. Let's journey back in time, nearly 4.5 billion years to the formation of Earth. Amidst the chaos of colliding celestial bodies, a beautiful blue planet was born. Its surface was volatile, its atmosphere inhospitable, yet in this seemingly hostile environment, the seeds of life were sown. Fast forward a few hundred million years, as Earth cooled and oceans formed, the stage was set for the emergence of life. But what was this life like? Well, it wasn't the dinosaurs or even the first plants. Instead, it was humble, single-celled organisms. These microscopic beings, invisible to the naked eye, were the pioneers of life, the first to brave the new world. They thrived, evolved, and set in motion the grand story of life on Earth. So, the first dance of life began with these single-celled organisms, setting the stage for the symphony of life we see today. Single-celled organisms, the pioneers, were the first to explore the realms of life. These tiny adventurers were humble yet resilient, simple in form but complex in function. They were merely a bubble of life, containing all the necessary components for survival. These components included a protective outer layer, a nucleus to store genetic information, and tiny factories, or organelles, to produce energy. In the harsh, volatile environment of early Earth, these single-celled organisms learned not just to survive, but to thrive. They reproduced by splitting in two, a process called binary fission, creating generations of offspring identical to themselves. Over hundreds of millions of years, these organisms evolved. Random mutations in their genetic code led to new characteristics. Some mutations were beneficial, enabling the organisms to better adapt to their environment, and these traits were passed on to future generations. These tiny life forms were the building blocks that paved the way for more complex species. They were the unsung heroes of life's grand opera, the first chapter in the epic of evolution. The single-celled organisms didn't remain single forever. They started dating. Metaphorically speaking, of course. In the grand scheme of life on Earth, the leap from single-celled to multicellular organisms was a game changer. It's kind of like moving from living alone in a studio apartment to sharing a bustling multi-room mansion with a bunch of roommates. It's a whole different ballgame. You see, single-celled organisms like bacteria are simple life forms. They get by just fine, but there's only so much one cell can do. When cells started to group together, forming multicellular organisms, that's when things really started to kick off. These multicellular organisms had cells that specialized, taking on different roles. Some were responsible for gathering nutrients, others for defense, others for reproduction. This division of labor allowed multicellular organisms to become more complex, more efficient, and more adaptable. This transition marked a turning point, leading to an explosion of diversity in life forms. The journey from a single cell to the plethora of life we see today is nothing short of miraculous. Let's take a moment to digest this. We began with simple, microscopic organisms, taking their first breaths in the primordial soup. These pioneers of life, the first species, heralded the dawn of biological evolution, setting the stage for an intricate ballet of adaptation and survival. The profound impact of these early life forms on Earth's environment and the evolution of more complex organisms is undeniable. They introduced oxygen into our atmosphere, paving the way for aerobic life and shaping the world as we know it. They were the first to master survival, and their evolutionary strategies have been passed down through the eons. The tapestry of life has been woven with threads of their existence, their struggle, their triumph. The legacy of these early pioneers lives on in every living creature we see today, including us humans. Remember, we all started from a single cell.